All right, welcome. So I'm Jason Pfeifer. I'm going to talk to you guys about, can't see anybody, but talk to you guys about network elements, putting Puppet agents on network elements, what we can do in that space, and basically automate the networking side of the data center now. So why do we want to do this? We've shown through Puppet that we can automate server technologies in seconds, minutes, where previously it used to take days to spin things up. Why can't we do this yet with the networking side? Why does it take orders of magnitude greater to spin the networking side of the data center up? There's been many people and a lot of money spent to determine that automation works and lowers the cost, right? From agility, some of these numbers here, 60% of the IT managers are not satisfied with the speed at which IT operates. So, how do we fix that through automation? Reliability, productivity. 48% of IT professionals are spending 50% or more of their time on basic administrative tasks. And so, all of these challenges in IT really apply to the networking space as well, right? So, the source of this slide is several disgruntled network administrators saying, rollout speed of network equipment is slow. Configuration after that and applying change should be immediate, but it's not at this point. There's a huge cost to manual configuration errors. And also tons of home-built scripts, that are specific to one data center, right? Nothing that can be shared, nothing that's common. If somebody leaves a company, what happens to the network at that point? And also, when change is applied, what happens when something goes wrong, right? The tools in the networking space to recover from problems has been traditionally weak, right? So now with these automation technologies that have spun up, we can start automating those problems away. The existing management solutions are insufficient. So in the IT space, you have a lot of scripting, right? You have custom one-off scripts, things that are not reusable. And then again, what happens when the original author of the script leaves, right? The script gets thrown away and somebody else writes something different. The NetOps space, it's basically the same thing. Question for you guys, does anybody know what the tool that is being used on the right side there? Expect, right. So, we see a ton of expect scripts. But the infrastructure for Puppet will allow us now to automate various layers in the networking stack, right? You can spin up physical and virtual nodes. You can spin up operating systems, configure operating systems. So, as you may know, Cisco has multiple operating systems on our devices. So how do you accommodate for that? You can start using automation to do that. Spinning up controllers, configuring controllers, and then all the way up to applications and from there. And this whole feedback loop of Puppet and automation applies to that as well, right? You can discover, provision, orchestrate, and report. Apply that at all of these levels in the networking stack, and you'll start to really see reduction of issues and problems. If we take the traditional Puppet agent, distributed agent, central management server workflow, you have it applying to hardware nodes, virtual machine nodes, cloud nodes. Why not the switches and routers as well? So you'll see, down below, we can have a distributed agent that's sitting directly on a switch, doing configuration, and tying into the traditional workflows that you guys are already working with the IT space. So let's talk about a few enabling technologies that is letting Cisco do this, letting Cisco put these agents directly on box and interacting with our operating systems. Here is a picture of the Nexus architecture. So I've starred the pieces that are important for this technology enabling this. So one of the things that we have, again, starting from the left, we have container technology. So being able to run a Linux container directly on device in a protected environment, in that Linux container environment, to allow you to run Linux flavor applications directly on the network elements. So you're not proxying in. You actually have your agent sitting on device running, doing even doing local order analysis if needed. You have shell access. You have CLI management. And then a key piece there is the NX API, which allows us to do programmatic interaction between the host operating system and the applications that are running in that Linux container. And then also this thing called 1PK, which is a set of libraries and APIs being provided by Cisco to interact with our devices. So all of those pieces make up a set of architecture that allows us to run with a Puppet agent locally. So a little bit about NX API. Basically what NX API is configuring over a HTTP link and basically sending JSON in and getting JSON data out. So you have well-formatted data that you're getting back from the device when you want to configure something. And that makes it nice. It reduces the need for screen scraping, and it opens up the possibility of doing more things programmatically, right? So here's a sample format of JSON in with a show clock. The command that comes in is just like a traditional CLI command in that command buffer, but it comes back as formatted data coming back. So in this case, you see at the bottom, the clock output comes back. And that's a configurable option on the devices. You can turn that on and off. Here's a bigger example of output here. This is show version output. So now, I don't know if you guys are familiar with the show version output that comes back from our switches. Now you're getting just a big blob of text, right? Now with this NX API approach, you have these JSON formatted name value pairs of data coming back from that show version output. So it's very easy to get what is my actual version that I'm running? What is the kickstart version of the image that I'm running? Date time, build times, things like that. So that stuff's all available to you through that interaction now. And then 1PK itself is, again, it's a set of libraries that we're providing to allow users to interact with our devices as well. So the idea of 1PK is to be able to extend the network elements, customize, enhance, modify, all that good stuff, right? And the way it works here is we have an abstraction layer that sits above the different operating systems and allows us to present a common API that allows you to write applications against that, regardless of which box type that you're talking to, whether it be a Nexus device, whether it be an iOS box, whether it be an iOS XE box or an iOS XR box. So the idea here is let's have one consistent set of APIs we can write to and allow users to use. So the top layer there, the presentation layer, is where we actually provide libraries and header files, documentation, all that good stuff. And that is released to the customer as C packages, shared objects, header files, Java jars, Python PYC files, allow you to link against those libraries and have your application off and running there. There's an IPC channel that's a pluggable transport. The nice thing about that is it actually allows us to run those applications in multiple locations. So 3 different locations where you can run the applications. 1 completely off box, connecting in through a secure socket link. That's great for network management type applications, right? One-to-many connections. You have one application, could be a controller, whatever it may be, connecting to each of the network elements and configuring at mass that way. Or even getting and setting data as well. Running resident to the box, either on a hardware blade, on a line card. So in that case, you have dedicated CPU memory resources. You're not sharing that with the route processor. And more of a medium latent connection. You use the backplane for the connection between the RP and the line card. So faster than an off-box TLS connection. And then at the bottom there's the process level hosting. That's where you're actually sticking the application directly on the RP in a container type environment where you're ultra low latency connection, just doing tip-C process-to-process communication back and forth between the app and the underlying operating system. And that's where we're running with the Puppet agent. We're running it directly on the RP in an LXC container. So what can you do with the API? A lot of the stuff on the left side, so traditionally we've had a lot of disjoint ways to interact with the boxes, either through CLI, through SMP, all the way down to the pieces that you can't see, the spanning, basically getting packet information that's packet data that's flowing through our devices through turning on a span port, something like that. But now the idea with this API is let's provide all of that information through this one consistent interface. So that's the idea here is it'd be nice if we can start getting rid of some of those protocols, I guess, and use only the API. Don't know if we'll see that in our lifetime, but it's a goal, right? And you'll see there in parentheses we have Ruby listed as also a language that we are supporting. Now in parentheses and with an asterisk because we're not supporting that externally for customers to write applications against, but we can use that internally to write a Puppet agent against, right? So it's a very nice interface that we've created through this 1PK API because it allows us to generate bindings in multiple languages. If we want to flip on something to generate a Perl set of bindings, you can do that as well. So we've done that. We've created a set of Ruby bindings, and that's what we are using on our Puppet agent to do configuration and manipulation. So, a little bit of the details here. Don't want to get into this too much, but there's a wide range of services that we offer, different layers of services through the API, working all the way down at the data path level where you're actually seeing packets coming through the box. You can register using something like policy to say, give me a certain type of traffic and send all of that traffic up to my application. So that's working at the data path level. If you want to manipulate flows, there are APIs to manipulate flows too. So that allows us to write things like an open flow agent directly on box as well and manipulate bypass, drop, whatever flows, whatever you want to do with those flows. Routing service set is everything that has to do with routing, manipulating the RIB, injecting routes, pulling routes off the box of what are configured, or at that point in time, what are the routes that are in the RIB at that point in time, and also receiving notifications when route state changes. And you can pull that information back to your application and take action if something occurs. So there's a full eventing mechanism that traverses all of these service sets as well. A strong eventing infrastructure so you can register for changes on the device and get callbacks basically when those changes occur. So if something drops from a route, something gets added to the RIB, go ahead and trigger my application, and I'm going to do something to recover from that, right? The element service set is everything basically what is conceptually a network element, things like interfaces, memory statistics, CPU, all that data is pulled through that element service set, and then working down through topology, seeing what is the network elements feel of the topology around it, working down to utilities and developer service sets are basically things written to help the developer develop applications, things like turning on debugging, even interface or interacting with the CLI. So if you want to add and remove keywords directly on the CLI itself, or add keywords, I guess more than remove, but add keywords onto the CLI, you can do that through that CLI extension piece. So that's 1PK. And that, that ability to put applications directly on device really opens up different types of modeling that we can do. And in the DevOps world, the idea of agent master communication is hot, and it's something that we can now do on devices, right? So you can have a 1PK agent that's talking, or an agent that's talking 1PK southbound on the network element, and then maybe a separate protocol talking back and forth between a controller. So that could be OpenFlow, right? The OpenFlow protocol between there. You can have a controller talking to multiple agents, multiple boxes, or you can even have 1PK applications sitting off box talking to 1PK applications sitting on box and going through the 1PK eventing mechanism to send and communicate back and forth between applications. You can do that as well. So with these technologies, that has allowed us to create device plugins, right? So things like an OpenFlow agent, things like a Puppet agent, and put those applications directly in a container so they're safe, they run on box, they are fast, and we can also release them separate from the traditional Cisco release cycles, right? Which is a huge benefit. So we can affect change a lot quicker through the agent. If somebody wants a feature that does not exist, now they have the opportunity to write it themselves if they want, right? You can do that, or you can interface with an agent team to develop a feature directly on box and not wait for the next release of Cisco software to come out. Okay, so I'm going to go into Nexus Puppet integration now. So you have this traditional workflow. Compute storage servers are being spun up through your master talking to your agents. Now let's add in the network elements, right? Let's bring in Cisco Nexus devices tied into your workflows. So as you're spinning up servers, you can affect change onto those devices as well through that same workflow. And that's what this is all about, is being able to tie in to workflows that are already being done at your locations, and now do it on the networking side as well. So this Cisco Puppet plugin architecture is basically, we have the agent sitting on box. It's talking either 1PK, NX API, whatever it may be. Those are just implementation details underneath the agent. But having that agent talk out through the Puppet protocol back and forth between an external master and the agents running on box. So one of the cool things that we've done also with this integration is actually tying in configuration commands to interface with the agent itself. So if you have a user that loves the CLI and does not want to drop into an LXC container to affect a conf file or something like that, they can actually configure their Puppet agent through the CLI now as well. So you can flip on things like, what VRF do you want to run in? Where's the Puppet master located? IP address. Do I want my Puppet agent to run with the traditional refresh cycle, or do I want it to run faster or slower? Or even not run as a daemon at all. Maybe you just want it to run in one-shot mode that you can affect the change. So all of that stuff now is tied in through our traditional CLI commands. Log output from the run of the agent can be seen through show commands. You can turn on debug commands. All that good stuff, all the logging available through the Puppet agent logging mechanism is now brought over to the traditional network element logger as well. So nobody has to drop into the LXC container if they don't want to. Here's a sample of that. So sitting on a Nexus device, conf t, type Puppet, you get into a Puppet sub mode. Point to where the master is. You can do that through IP address and optional port. Set up saying I want to configure this, or I want this interface interaction to go through the management port. Set up a run interval. The Puppet agent at that point is going to run as a daemon when you hit activate there, and wake up every 180 seconds and contact out to the master. And then you can provide some other domain name server type information as well. So again, that's traditional iOS or Nexus CLI there. When we start talking about zero touch, there has to be a way to get that agent onto the device to start with, right? And there's mechanisms in place to allow that from a completely zero touch standpoint. So you plug in a box, does a DHCP request out to a DHCP server. The request hits the DHCP server, and that basically in turn sends back something like a Python script that is run locally on the device, and that's power on auto provisioning. That's that feature of Nexus. And what that does is that allows you to trigger that Python script immediately and provide some information into that Python script to say, well, where is this Puppet agent that I want to run and use? So what you can do is actually have the DHCP server point down or push down a Pope script that says, and some information along with that, that says, here's your TFTP server, go out and download this OVA file to the boot flash, and then spin that up, right? So minimal configuration, it's all hands off. You know, if you plug in and turn on a device without any configuration, it automatically starts doing this POAP interaction, right? So with that, you can actually download that Puppet OVA, fire it up, and then let it take over, and from there on out, you do the rest of your configuration. So that's an option for complete hands-off, zero-touch deployment there. Now, you know, what are the use cases, I guess, for this, right? Multiple use cases. If you want to do patching, that's supported through this agent. So if there's point fixes and your box supports point fix upgrades, it's a great use case for you know, managing that patch interface or interaction, right? New server VM deployment. So if you're spinning up servers, you need to put VLANs between servers. You know, another good use case, right? Things that are changing quite a bit that you can do in a more hands-off fashion. And then the last one there is an entire configuration distribution. There's types and resources in the Cisco set of types that allow you to actually push down entire configuration if you want to. And you know, we'll talk about that a little bit. So here are the types. This is our initial set of types that we're rolling out with. And again, you know, the idea here is to hit the top of rack type features, the things that are changing most often in general, and then continuing to expand that out as we go forward. So things like configuring interfaces, L2 and L3 data on the interfaces, configuring VLANs, creating VLANs, destroying VLANs, creating SVIs, working with VTP, and then also, you know, hitting some of the stuff that changes a little bit less, but, you know, setting up SNMP information, OSPF configuration, things like that. And then the TACX as well, so you can set up TACX. But the last one there, the raw CLI commands, this Cisco command config is pretty powerful because what it means is everything that we do not have a type for yet, you can actually push down the rest of the configuration if you want to. So that allows you, that's, you know, that's kind of the catch-all for everything else. And then from all of these base types, you can build up higher order types using this, and you know, basically do what you want from there. These types are, so recently the NetDev2 types have been developed and released by Puppet as well, and these types have a lot of influence with those types. We've been working closely with Puppet Labs at Cisco to develop this NetDev2 library, and you know, we have providers that are in the works to interface with that as well. So the providers that are working behind the scenes here are going to be the same providers for the most part as the NetDev types as well. All right, so let's take a look at a demo. So this demo, I know it's going to work because it's pre-recorded, so we don't have to worry about a crash here, but let's go ahead and get through this. So what we see here, this is, I want to show you guys this setup here. This is a tool that we're working on called Viral. And what Viral is it's a way to spin up networks basically in a virtual environment, a testing environment, provide a GUI to allow you to drag and drop the network that you want to simulate, and then from there basically spin up the network and you know, run with it. So basically what it is, it's a layer that's been put on top of DevStack to you know, control DevStack underneath it, and make it really easy to create your network infrastructure that you want to simulate and, you know, virtualize here. The cool thing about it too is it doesn't have to be network elements. It can be servers that you can spin up as well. So, you know, if we take a look at this network, and this is called Viral, VIRL. If we take a look at this network here, we have a Puppet Agent 1, Puppet Agent 2, and Puppet Agent 3. And I'm going to go ahead and manually just move this forward. So this, this is a GUI network builder, right? Here's our Nexus nodes at the top. So that's simulating 3 instances of Nexus V, so the virtualized Nexus software. And then down at the bottom, we have a couple server nodes. So we have a web client, which is basically just a tiny core image that has a web browser on it, right? And then on the other side, we have a Puppet Master, and that's an Ubuntu instance, and it has a Puppet Master running on it. One of the things that Vyral also offers is some auto-generation of configuration as well, so it's called Auto Netkit. And so if you want that to be in place, you can get some, you drag a couple links together, turn on Auto Netkit, and that'll generate some base configuration for you when you spin the nodes up. So I'm just showing that here. And then also, you can see down in the window here that I am confirming that this is a Nexus V image that's being spun up as the type of the image. And again, this is all OpenStack, so these images are put into Glance, and then they can be spun up through that mechanism. And you can add and remove more images from Glance if you want to. And as we roll out new changes, we can put that behind this Vyral mechanism. So as we move forward, there's that Ubuntu Puppet Master instance as well. So you can see here in the upper right window that we have the simulation already up and running. So we have those 5 nodes that are spun up. The instances are off and running at this point. So if we go ahead and let's flip over to actual terminals, we have the 3 terminals at the left there. That's the Puppet agents. That's basically just I've telnetted into those boxes, and you can see those boxes running. And on the right side, we have a Puppet Enterprise dashboard, right? So if you look closely, though, this is basically what that is we're running NoVNC to get into that tiny core web client through NoVNC. And then from that tiny core web client, I just point my browser over to the Puppet Master, and that gives me access to the dashboard. Right? So here's the Puppet Enterprise dashboard. If we zoom in there, we'll see that we are managing all 3 of those Puppet agent nodes. So there's the 3 nodes running. And then we come back. So there's a set of virtualization commands on the devices that show you which containers are running. So in this case, it's a show virtual list command. That lists every single LXC container that is running on that device. In this case, I have one running. It's the Puppet LXC container. And that was provided through an OVA file, right? So Puppet OVA final, or Puppet final OVA running here. And that's been activated. So it's up and it's running. Go a little bit further here. So what we're going to do here is we have the 3 nodes. We have 2 links between the nodes, and those are on separate broadcast domains. So we'll set up some IP addresses on Puppet Agent 1, and we'll treat these as route ports, not switch ports in this case. We'll have an IP address on Puppet Agent 3 and Puppet Agent 2, and we'll see that we can't ping back and forth between 1 and 3. But as we spin up and run Puppet, what that's going to do is that's going to enable OSPF onto the devices. It's actually going to do the configuration of the IP addresses as well. Spin up OSPF, and then we'll see after we run Puppet on all those nodes, we'll be able to ping back and forth between 1 and 3 because OSPF will be running at that point. Right? So if we take, let me move down further here. So let's take a look at the manifest real quick. How are we going to actually make this occur? So if we look at the manifest, basically what we've done, hopefully you guys can see this, it looks pretty small, but basically we set up a regular expression to say, for all the agents, so any Puppet agent.star, let's set up some VLANs, and that's just some samples. This is how you set up a Cisco VLAN, right? We'll have a VLAN with an ID 400, ensure that it's present, give it a name, make it active. We'll do the same thing with VLAN 500. So that's just a sample to show that we can spin up VLANs, right? The good stuff comes after that in each individual node. So if the node is Puppet Agent 1, let's go ahead and put an IP address on interface Ethernet 2/1. Make sure it's not a switch port, it becomes a route port. Make sure it's running, give it some description, set an IP address for it. So in this case, on the Puppet Agent 1 side, we have the 20.10.10 network, right? And then also underneath that configuration of the interface, let's set up some OSPF information. So OSPF area 200 here. And what we're going to do is we're going to set up that OSPF instance on all the nodes with that same area. And just by doing that, it's going to give us that connectivity between devices there. So if we move forward to Puppet Agent 2, so again, there's data for all nodes, and then there's node-specific data as well in that manifest file. Go down to Puppet Agent 2, same thing, just one more interface, right? So we have the side that's going to Puppet Agent 1, we have the side that's going to Puppet Agent 3. So we have two interfaces that we're configuring, two different networking addresses. So we have the 20 network on the one side, we have the 30 network on the other side. Again, running OSPF, and then Puppet Agent 3 here has the IP address of 30.10.10.2 on the interface Ethernet 2.1, right? So by giving those IP addresses and that OSPF configuration in, we can go ahead and ping back and forth between 1 and 3. So now let's go back to the devices. In this case, I'm not running my agents as a daemon, so I'm just going to affect change by manually forcing the agent to wake up and run. And I've actually created well here, let's go ahead and take a look at the interfaces first. So if we do show run Ethernet 2.1, we see that it's currently a switch port. It has no IP address information, has no OSPF information on it. It's up, but it's not a routed port. If we take a look at OSPF as well, there is some OSPF information, but that is not the 200 instance, right? That is just doing some management type stuff. I will glance over that. But that is, that's not contributing to this instance that we're working with here. On the other devices, we can do the same thing, show an E2, switch port, Puppet Agent 3, switch port. So no IP information in. Let's go ahead and now run the Puppet agent. So I do a Puppet run, and that's just an alias I set up to do an execute command to cause that Puppet agent to run. We'll go ahead and do that same thing on all the devices, 1, 2, and 3. And then after the agent runs, we'll do that show in E21 there. And now we have the configuration of the description. We have it's no longer a switch port, it's now a route port. We have the IP address set in. We have the OSPF information for that interface set. So all of that through that manifest that we had shown earlier there on the right side. Show OSPF information. So now we have the interface 2.1 and then the specific OSPF information for that interface. Go back to Puppet Agent 2. We see the configuration in place. Puppet Agent 3, the configuration in place. Show IP route shows, so this is on Puppet Agent 3. Show IP route is showing that it has a connectivity over the 20 network, and that is through OSPF, right? So there's that configuration that has been spun up through that Puppet agent. And then one more, there's our ping, we can ping back and forth. And then one more little cool tidbit here, I guess. On Puppet Agent 1, we have one more VLAN that's been created, VLAN 600, with a VLAN name of dashboard. So in that case, we're not creating that VLAN through the manifest file. We're creating that one directly through the Puppet Enterprise dashboard. So let's go to the dashboard real quick. And we can look at Puppet Agent 1, and we can see that we've added a class directly through the dashboard, the Cisco VLAN class. And then moving down here, take a look at the parameters for the class. And there's the name, there's the state, there's that VLAN ID 600. So that matches what was pushed down from the dashboard side down to the network element as well. So you can do configuration through manifest files, through YAML files, through dashboards, whatever it may be, all tied in back to that agent. And that's it. So that's all I have. If any questions? Sure.
So all of this in your demo is?
All of this in the demos regarding Nexus switches.
That's correct.
And they're running the agent locally. For other devices, it seems like you are going to allow to have an agent run on a intermediary system to send the same type configuration changes?
So writing a proxy is a possibility to connect in to devices. Our other platforms support technically running an agent locally as well. Not iOS Classic, but iOS XE, XR, and a line card. Work is being done, and it's technically possible to do it. Right now, we're not exposing that externally. Hopefully, that'll change to be able to run an agent locally, almost cross-platform, right? iOS Classic is always going to be a challenge, just the way it's designed, right?
But the intermediary approach is...
That would still be, that's possible. We're working on it. I don't know if it's going to be an official product or not, but it's pretty easy to run an agent externally and still make use of the same types and providers to be able to affect change from that proxy. Yeah.
Is this included if you buy a Nexus switch, or is it an additional license, or how's it being delivered, and is it available today, or is this something that's coming?
It is available in EFT controlled availability. Yeah, today.
Controlled availability, so you have to go to it. It's not on Cisco CCO, but you basically can work with.
Yeah. So if you're working with an SE, talk to your SE, and they'll be able to get it to you.
Get you access to it.
And then as we continue down the path, it'll eventually be a. I don't know if it's going to be charged or not actually, but it will go to general availability.
And you asked about platforms, so it's on the Nexus 3000 and about to release on the Nexus 9000.
Nexus 3000, Nexus 9000 is well.
5,000? In the next quarter
Yeah.
is the plan.
5,000. The rollout plan is 5K, 6K, 7K, a little bit further down.
You've shown the Puppet agent on the enterprise console. Does that mean you have also mCollective running on the Nexus devices, so you can also do the orchestration?
The question was about mCollective running in that agent directly on box. If we scroll back a little bit here, back to the dashboard. Yeah, let's see if I can catch it at the right spot here. If you look in the group there, we have no mCollective class running, so we do not have mCollective running on the device yet. There's work in progress to make that happen, and we're working directly with Puppet to do that, Puppet Labs to do that.
So whatever happened to NetConf?
Whatever happened to NetConf, it's still on its way, right? It's still, Cisco is committed to supporting NetConf, and with the acquisition of TailF, that is probably only going to get better, right? Many ways to interface with our boxes, whether it be NetConf, whether it be NX API, whether it be 1PK. These are all different ways of programmatically accessing the box that we are pushing forward with, and that's the whole goal here.
Are you looking at any of the DMTF standards?
I have no comment on that.
Probably the best answer.
Anything else? Awesome. Okay, so if anybody wants to see a live demo, I know this one was recorded. We have it running live too. If you have any other questions, let me know. And if you want to run this stuff, talk to your SE. We can go ahead and get it to you.
Thank you, Jason.
Thank you.